Hello everyone, welcome back. Myself Sujit Sali, lecturer in Mechanical Engineering Department. In previous video, we have seen two different types of process. Those are isobaric and isochoric process from the chapter Thermodynamic process. So in this video, we cover another type of process, that is isothermal process. Its explanation. What do you mean by PVT relation? That is pressure, volume, and temperature relation. And finally, we end the video with derivation for work done during isothermal process. Okay, so let's go through isothermal process. So what do you mean by isothermal process? So this isothermal process can also be called as constant temperature process. In the sense, okay, so during this process, and the system changes its states from one state to another, that is from initial state to final state. But during this conversion or during this change, the temperature of that system remains constant. So the temperature of that gas remains constant. Okay, so how that happens, we'll see it here. So you can see now here there is this cylinder same like earlier and piston arrangement, and below this piston there is a gas, or what we call it as a system, and just below this cylinder we have a heating source. Okay, so same like earlier, this is a heating source also here. So now when the heat is supplied from this heating source, it is supplied to the gas. So the gas starts expanding. Okay, so that due to the expansion, what happens, the gas pushes the piston and piston starts moving from its initial state and it reaches to final state. Okay, so the heat during this process, okay, so this process what we call it as constant temperature process. So during this process the heat is supplied in such a way that the temperature of the gas remains constant during the expansion. In the sense, the temperature, okay, during this process the heat is added continuously and gradually, okay, such that the temperature of the system remains constant during the expansion. Hence it is called as constant temperature process or isothermal process. Okay, so the temperature remains constant during this process. Okay, so how that achieved is achieved by heating, or the heat is provided to the gas gradually and slowly. Clear? Okay, that same process is plotted here on PV diagram. Okay, so you can see here earlier this point 1 is your initial state and point 2 is the final state. Okay, so the arrow, it is moving down, that is from point 1 to 2 it is moving downwards. So when the arrow is moving downwards, we will say that the process is expansion. Okay, when the arrow is moving upwards like this, we will say that the process is compression. Clear? So during now the gas is expanding, that's why the arrow is down, that is from point 1 to 2. Okay, so at point 1 the initial pressure and volume will be there. Okay, when the heat is supplied to the gas, okay, so the gas starts expanding. Okay, during this expansion what happens, the pressure decreases and the volume increases. Okay, during this expansion what happens, this expansion, the volume of the gas increases, the pressure goes on decreasing. Okay, and finally it reaches at point 2. Clear? So we'll see here. Okay, there is small animation you can see here. Okay, so you can see in this process the temperature is remain constant. Okay, this is your thermometer. Okay, it is measured, that is used to measure the temperature. So you can see now the expansion is taking place, the piston is moving upwards, but the temperature remains same. Okay, and simultaneously you can see there is a PV diagram, it is plotted. Okay, the curve you can see it is coming downwards, means the pressure is decreasing, the volume goes on increasing. Okay, so during this process the temperature remains constant, only the pressure and volume changes. Clear? So next we will see the pressure, volume and temperature relation during this process. Okay, so the general equation is given by PV divided by D by T is equal to constant. So in this process what happens, the temperature is constant. Okay, so the temperature is constant in the sense, what happens, this temperature T, it becomes 1 because the temperature doesn't change. Okay, its value remains same throughout the process, that's why its value becomes 1. Hence this equation we can also rewrite it as PV is equal to constant. Okay, so now next what happens, this it can also be written as P1 V1 is equal to P2 P2, that is pressure and volume at point 1, this pressure and volume at point 1 is equal to pressure and volume at point 2, that is pressure and volume at point 2. So this is the PV relation during isothermal process. So we don't have T here because T is constant, so it becomes 1. So hence only the variable are its pressure and volume. Okay. So next we'll go through the derivation for work done during isothermal process. Clear? So in this you can see this is the derivation. Okay, so now consider a unit mass of gas, that is M. So that is the mass of the gas, whatever we have taken, it is 1 kg. Okay, So the general equation for work done is given by W is equal to P into dV, that is pressure into change in volume. This dV is nothing but change in volume, that is V2 minus V1. Okay, so this is the general equation for work done. So now what I'll do is I'll apply and integrate. I'll integrate this equation using the limits 1 to 2, that is from 1 to 2. Okay, so how can I write this? That is integration 1 to 2 P into dV. Clear? So now this PV, okay, so we have seen that earlier, the relation between pressure and volume, that is PV is equal to P1 V1 is equal to P2 V2. Clear? So this P I can rewrite it as what? P1 V1 by V. Okay, this PV is equal to P1 V1. I can write it as P is equal to P1 V1 divided by V. So instead of this P value, what I'll take this whole value. I'll shift this P value into this P1 V1 by V. So here I have written it as P1 V1 divided by V. Okay. So now next, this P1 V1 is a constant. Means at point 1 P1 V1 is same, it doesn't change. Okay, so that's why it becomes constant. So what I'll do, I'll take it outside. So I'll just integrate 1 to 2 using the limits 1 to 2 dV by V. Okay, so V is only variable here. Okay, so V can be V1, V2, V3, V4. So only V is variable, P1, V1 is constant. That's why I've taken that outside. Okay, so this the integration of 1 by V, or simply you can say the simple integration, that is 1 by E, can also, what we can write it as log of E. So same way what I have done here is, okay, so P1 V1, so integration of 1 by V, it can be written as log of V to the limits 1 to 2. So when I use these limits inside, what I can write it as P1 V1 in the bracket log of V2 minus log of V1. Okay, so that is log of V2 minus log of V1. Okay, so this log of V2 minus V1, how can I write it? W is equal to P1 V1 log of V2 by V1. So this is your general, or what we call it as, a work done equation during isothermal process. Okay, so this we can also write it as, okay, so we have seen earlier, that is pressure and volume relation at point 1 and point 2, that is P1 V1 is equal to P2 V2. So instead of writing P1 V1, what I can write? I can write it as P2 V2. Hence W, I can write work done formula as, instead of writing P1 V1, I have written P2 V2 log of V2 by V1. Right? So now in terms of, so instead of using V2 by V1, I can use P1 by P2. Okay, how I got this? I got this from this equation. Okay, that is P1 divided by P2. If I do it, what will remain here is V2 by V1. Okay, instead of writing V2 by V1, I have written it in terms of pressure. That is, instead of writing in terms of volume, I have written in terms of pressure. That is, W is equal to P1 V1 log of P1 by P2. Clear? Okay, so again I can write it as, this equation resembles this, only here V2 by V1 was there, here P1 by P2. Same way this equation resembles this equation. So instead of V2 by V1, I have written P1 by P2, that is P2 V2 log of P1 by P2. Okay, so this is, or these are the equations that you can use, and these are the equations that are used for finding the work done during isothermal process. Okay, so based on the given data, you can use any of these formulas. Okay, for example, now they have given only the initial volume, that is V1, and they have given the final pressure and, sorry, initial pressure and final pressure. At that time you can use this equation. Okay, so based on the given data in the problems, you can use one of these formulas. Okay, so now the important thing you can note here. Okay, so while solving the problems, okay, so this log, while using this log in the calculator, or while solving the problem, while substituting, you have to use this one, that is LAN. You can see here LAN they have given. Don't use this log. Okay, if you use this log during substitution and finding the answer, okay, your whole answer will be wrong. For that reason, this log is nothing but this LAN. Okay, so you have to use, while substituting in calculator, P2 V2 LAN of P1 by P2 or V2 by V1. Clear, guys? Okay, so use this LAN while substituting or while calculating the answer. Don't use this log. Clear? So I think you have understood. Okay, so we'll cover in next video, we'll cover the remaining processes. Clear? Okay, fine, thank you.